Hello, hi, good day, folks. So, today we'll be discussing about types of roots. Alright, there are different types of roots, three to be specific, and we will be going through each and one of them a little bit on this class. So, let's start with this quadratic equation. So, the reason why we learn this, essentially, you have to start with what do you know about roots? Roots are basically the points that supposed to intersect the x-axis, especially when you define your fx equal to 0. Just to give you a flavor about what roots are. Let's say you have a quadratic function as such. This is your x, this is your fx. In this case, you have your intersection points. As I mentioned, the points that intersect the x-axis, which are first point over here and then the second point over here. At these points, your fx is equivalent to 0. So your y is equal to 0. That's where you get your roots. Alright. So in this case we have two roots. Okay. So two real roots, and both of the roots are different. They are not the same. They are different numbers, obviously, because they are at different location. So here we call it as two real and distinct roots. Alright, this is one of the type, just to give you a flavor. Alright, so let's start with our first example. So our first example is 2x squared negative 10x plus 8. Alright, and how you going to define what are the roots in this equation? We start with this formula, which is b square negative 4ac. This is the formula used to define types of roots. Let me show you how powerful is this formula. Okay, so we start with this first quadratic equation. As you can see, 2x squared negative 10x plus 8. So the first number here, so the general formula for your quadratic function is this. Alright, so your a is positive 2. Alright, so a is positive, which means you have minimum graph in this case. When your a is negative, as I mentioned in your previous video, when your a is negative, it is a maximum graph. Okay, and your b is negative 10 and your c is 8. The formula states b square negative 4ac. Start with b square, which is negative 10 square negative 4, and your value for a is positive 2, and then we put that as 2, and then your c is 8. Alright, negative 10 square is 100, and then you have negative 4 times 2 is 8 times 8 is 64, and now you end up with 36. Alright, so when you do your analysis, b square negative 4ac, you get 36. And how you can use this analysis to identify your type of roots? First is look at the number here. The number here is greater than 0, so your b square negative 4ac greater than 0. If the number is greater than 0, that means you will have real and distinct roots. Okay, real and distinct roots, when you draw the graph, you should have two intersection points on this graph. That means when you solve for your roots, you should get two values for that. So let us do a proper checking on this. And how do we check? Let me check over here, and I start with my equation. 2x squared negative 10x plus 8 equal to 0. So if you want to find the roots, what you have to do, you gotta factorize. You have 2x, on this side you have x equal to 0. Look at the number here, 8. So 8 comes in what multiplication? So basically you have to put two numbers. So you think about what are the possible numbers you can multiply to get 8. The most easiest one is 1 times 8. You have another one is 4 times 2. Alright, so let's check. I believe that 4 and 2 would work here, because if I put 4 over here, I can able to multiply this and I can get 8. If I put 2 here, I can able to multiply this, I get 2, and then 8 plus 2 I can get 10. And now my objective is to get positive, then I gotta put negative here, and now everything sorts out by itself. The way to do it, you can just simply use your calculator, and from there you can find your roots. Alright, so maybe on the next video I can put a little bit on simple techniques on how to find the roots, and in this lesson I just assume that you understood on how to find the roots. Alright, so if I want to find the roots in this case, so my x is 4 and my another x is 1. I draw a graph. So this is supposed to be a minimum graph, that means it's a smiley graph. So I have two distinct roots, so I have a graph as such. So my first intersection point is 1, the second intersection point is 4. And this actually something what we can see over here from the types of roots identification process. You can visualize this on your graph. You have real and distinct roots. Now let us do one more example. 24x equal to 9x squared plus 16. Before you start plugging in the formula b squared negative 4ac, first you gotta align the equation based on your quadratic formula. In case I have my bx value over here, I'm going to bring this on to the other side. So when I do that, I'll end up with 0 over here. I have 9x squared, and positive 24x is going to be negative 24x, and then I'm going to write positive 16. And I don't want to write this on the right hand side, I'm just gonna write it on the left hand side. So this doesn't change the equation at all. Now I have this defined clearly according to my quadratic formula, ax squared plus bx plus c. Now I can apply my b squared negative 4ac. So my b is negative 24 square negative 4, and my a is 9, and my c is 16. Solve this. Negative 24 square is 576. Negative times negative will be positive, and 4 times 9 times 16, it will be 576 as well, and 576 minus 576, you get 0. In this case, my b square negative 4ac equal to 0. What does it mean? When you have such cases like this, you have one same root That means the intersection on your x value is essentially at one point. So you can say it at a different way. You can put it together. You can say it as two equal roots, or you can say it as intersects at one single point. So how does this look graphically? Let me do a simple sketch. So graphically this is not quite accurate. I'm just gonna show you how does this looks like in the perspective of graph. This essentially will look like this, where the intersection will be at only one point. You have an equation as such: 3x squared negative 1 over 2x, and then you have negative 3. So what happened here? You gotta do the same thing: 3x squared negative 1, and then you have positive 3 equal to 0. And I'm doing the same formula here. My b here is negative 1 over 2 square, negative 4. My a here is 3. My c here is 3. Alright, so I'll end up with 1 over 4 minus 4 times 3 minus 12 times 3 minus 36. So if I simplify this, I get negative 35.75, which is less than 0. So my b square negative 4ac is less than 0. So what does it mean? So graphically, if you have such cases and you try to find your roots, when you plug it in your calculator, you wouldn't find roots as well, because there aren't any roots. And if you draw your graph will look like this. This is my fx, this is my x. This is just a simple sketch. How does the graph looks like for b square negative 4ac less than 0. This is not quite accurate, quite specific to the equation over here. Just a sketch to let you guys understand graphically how does this look like. These are the three types of roots that you have to learn. First is b square negative 4ac, and the solution for that, you get a positive number and you will get greater than 0. Positive number means greater than 0. Then you can say it as two real distinct roots. If you have a case that b square negative 4ac, once you have plugged it in them, you get equal to 0. That means you have one single root and your graph will only touch at one point on the x-axis. Or you can say it as two roots are the same. You can define it as such as well. And now you learn about b square negative 4ac less than 0, which means the graph doesn't actually touch the x-axis. That's all. I hope you guys learned something useful today. See you later on the next video.